The fifth question says integrate 2x upon x square plus 3x plus 2. How do we integrate this? First thing to observe, whether the degree of numerator is less than degree of denominator, whether it is a proper rational function, the answer is yes. So there's no need of division. Next thing, whether the denominator has been written as a product of linear or quadratic factors. This is a quadratic factor, but can this be factorized further? The answer is yes, this can be factorized further, x square plus 3x plus 2. Yes, and what else? X square plus 3x plus 2 can be factorized further. Other than that, do we need anything else? No. Once we factorize, after that, we can convert it into partial fractions and then integrate. Okay. Now, some of you may disagree with this particular algorithm. When you see this kind of a question anywhere randomly, okay, this is present in the exercise of partial fractions, so we'll think partial fractions, sir. But in case we encounter this question randomly, is it necessary that we go with the method of partial fractions? The answer truly is no, it is not at all necessary that you solve this question using the idea of partial fractions. What you can do is you can also use idea of linear upon quadratic over here. In one of the previous exercises which we saw linear upon quadratic, and there we use the formula of 1 upon quadratic, right? So for converting this into perfect square, we'll have to write it as x plus 3 by 2 whole square 2 minus 9 by 4, which is minus 1 by 4. So this is x plus 3 by 2 whole square minus 1 by 2 square, right? This is what you'll get. In the denominator, you have the form 1 upon x square minus a square actually, right? Oh, but there is a linear in the numerator, so that numerator has to be written as a times derivative of denominator plus b first of all, right? There will be two terms, you can integrate those two terms separately, right? That's what you will do. But linear upon quadratic is an approach which you can obviously follow over here. Once again, coming back, this question will be still easier with the method of partial fractions once you have mastered that, right? So in case you encounter this question randomly also, you should be able to see that, okay, sir, this can be solved by linear upon quadratic, this can be solved by partial fractions. Which of the methods will be easier over here? So the easier method for solving this question will be partial fractions by the way in which I'll discuss, right? So we have x square plus 3x plus 2, and let's take a look at this particular solution from that perspective. So 2x upon x square plus 3x plus 2. This denominator, I'm not going into the details of factorization, but this denominator can be factorized easily by splitting the middle term. This is 2, so 2 into 1, this becomes 2x and plus x. So plus 2x plus x, that will give me one of the factors as x plus 2, the other factor is x plus 1. In the numerator, you have 2x, right? Now, once you have factorized, convert into partial fractions. So this becomes a upon x plus 2 plus b over x plus 1. Okay, what about the values of a and b? Oh, we need some shortcuts. We have some shortcuts for finding the values of a and b. So, our shortcut, let us find the values of a and b in this box over here using that idea. So, for a, you'll have to substitute x equal to minus 2 over here by removing this. Yes or no? Yes. So, x equal to minus 2, this becomes minus 4, and minus 2 plus 1, which is minus 1, that tells me a equals 4. What about the value of b? We'll put x equal to minus 1 over here by removing this. This is minus 2, this is 1. So b equals minus 2 actually. Very interesting. Yes or no? Yes. So a equals 4, b equals to minus 2 is what I get, and this is a shortcut approach, right? Once again, for the board people, they are once again very lovely people and they want you to solve using another approach. So let's see the comparison with numerators. Numerators, throughout 2x is equal to a times x plus 1 plus b times x plus 2 is what I have. Okay, comparison tells me that coefficient compare these two. So in the right hand side you have some term containing x and some constant term, right? So term containing x, this coefficient of x will be 2, and on the right hand side it will be a plus b. On the left hand side constant term is 0, on the right hand side constant term is a plus 2b. Using these two, do you get the values of a and b? Yes. Subtracting will give me the value of b directly. B is equal to 0 minus 2, which is minus 2, and a therefore is equal to minus 2b, which is 4. A equals to 4, b is equal to minus 2. That's what we found, right? And that's the same thing. So After this, yes, we have converted into partial fractions. Once we have converted into partial fractions, next we can talk about integration, which is 2x upon x square plus 3x plus 2 dx has been written as integral of a upon x plus 2, which is 4 upon x plus 2 minus 2 upon x plus 1 dx. This is what you get. Is that okay? Yes. So integration of this, okay, this is 4 times log modulus x plus 2 minus 2 times log modulus x plus 1 plus constant. That's my answer for this particular question. As you can see over here in this fifth question, that's a complete solution. First finding the partial fractions, obviously before that we have factorized, and then integration, right? That is all that you have in this question.